On April 23rd, the Cornell Agritech Efficient Vineyard crew of Terry Bates and Heather Barrett traveled back to California to team up with Cole Gage at Vmech for another demonstration of variable rate mechanical shoot thinning. The first big question is about what we're trying to accomplish with mechanical shoot thinning and how does it compare to manual shoot thinning. Usually the comment is something like, a machine will never be able to do what a human does. My response is that yes, the machine will not do what a human does, but no, we are not trying to accomplish the same thing when comparing manual and mechanical shoot thinning. In manual managed cordon trained spur pruned vineyard, vines are hand pruned to leave 2 to 3 node spurs at regular intervals. Fruiting shoots originate from bud positions on the spur, often referred to by viticulturists as count nodes. Less fruitful or non-fruiting shoots can also grow on the vine at non-count node positions, such as at base buds and other adventitious shoots on the trunk or cordon. In manual shoot thinning, these low productive shoots are removed and count node shoots are retained. Consider manual shoot thinning more of a canopy management practice than a crop management tool because fruiting shoots are retained. In contrast, a mechanically pruned vineyard will leave a hedge of spurs with many more shoots per foot of row, and this will be a population of both fruiting and non-fruiting shoots. If left alone, the vines would set too large of a crop and have too high a canopy density. In mechanical shoot thinning, the thinning fingers strike the cordon at intervals to remove both fruiting and non-fruiting shoots. The main goal is to remove, or should I say retain, the correct number of fruiting shoots per foot of row for the desired crop size set by the vineyard manager. Based on 2 years of yield monitor data and current season NDVI, multi-layer data processing was used to generate a variable rate shoot thinning prescription map where we thin 10 rows and skip 10 rows, thin 10 rows and skip 10 rows. In this clip, the prescription map is loaded into AgLeader software and you can see where the machine is located in the vineyard. The rates are seen as gallons per acre because the AgLeader system is designed for liquid applications. We use the system to control the output to a variable hydraulic valve which controls the rotation speed of the thinning fingers. There is a speed sensor on the thinning head so we can translate gallons per acre into rotations per minute, and more importantly, to percent shoot removal. You can see as the implement enters a new zone, the rate changes on each arm independently and the rotation speed of the thinning head changes. So what about cost? A more complete economic analysis is needed, but a back-of-the-envelope calculation for California wine grape vineyards looks something like this, and you can certainly play with these numbers to match your own operation. The cost per acre to manual prune, sucker, and shoot thin will run about $930 an acre. To run the same task mechanically at 1 acre an hour with 3 operators making $20 an hour each will run about $180 an acre. So that is an estimated labor cost savings of about $750 an acre. The cost of the machinery is a considerable investment. To buy the trailer, pruning heads, and the cordon and shoot thinning brushes cost just under $200,000. Adding the variable rate technology will add another $15,000. If you offset the capital investment against labor savings in this example, in vineyards over 150 acres, it would take less than 2 years in labor savings to pay for the equipment. I'm neither an economist nor a salesperson, but if you are considering moving towards mechanized vineyard management, I think these numbers start you in the right direction. Thanks for watching. This has been Terry Bates from Cornell Agritech, Cornell Lake Erie Research and Extension Laboratory, and the SCRI Efficient Vineyard Project.